Method 2 for graphing a logarithmic function log base 3 of x is to evaluate the function for several x values on its domain and then use a smooth curve to connect the ordered pairs. So here are some points, x values that we're going to plug in. Let's start with 1/3. When I remove the x from the original equation and replace it with 1/3, I'm going to rewrite it in exponential form. And so now, what number do I raise 3 to in order to get 1/3? Well, you have a whole number. In order for it to turn into a fraction, remember it's going to be a negative. So this is -1, because if we raise it to the -1 power, we'll get 1/3. So our output is -1. Well, what if we plug in a 1? If we plug in a 1, rewrite it in exponential form, what number would I have to raise 3 to in order to get 1? Well, we know that any number to the 0 power equals 1, so y equals 0, our output. Next, we're going to plug in a 3 for x. We're going to rewrite it in exponential form. And what number would I have to raise 3 to in order to get 3? Yes, that's correct, 1. So our output is 1. And lastly, we're going to plug in a 9. We're going to rewrite it in exponential form. So what number would I have to raise 3 to in order to get 9? That's correct, 2. So y equals 2. So here are our 4 ordered pairs, and I'm going to go ahead and plot them on the rectangular coordinate system. And this is what our graph looks like. Now let's find the domain and range. The domain, how far the graph extends to the left and to the right. Well, for logs, a graph always starts there at 0. Now it does not include 0 because there's a vertical asymptote at x equals 0. So you will put a parenthesis around the 0, and then it's going to go forever to positive infinity because you have that arrow there. So our domain is going to be from 0 to positive infinity. Next, our range, how high and how low the graph goes. Well, you have arrows on each end, so it's going to go forever up and forever down. So our range is from negative infinity to positive infinity.